Hello guys, this is Raspberry Economics, and today we are trying to explain what Marshall-lerner condition is and try to prove it with some basic mathematical skills. So, firstly, what is Marshall-lerner condition? It is the sum of price elasticity of demand of export and import is larger than 1. From IGCSE and some basic economic studying, we know that if the currency depreciates, the trade balance and the current account will improve. However, that is not necessarily true. The trade balance will only improve if the Marshall-lerner condition is met. But why? Now let's analyze this in short run and long run respectively. Firstly, in the short run, the demand for both export and import can be considered as perfectly inelastic, so the quantity demanded will remain constant. And export is domestically produced goods, so the currency depreciation won't even affect its price. Remain constant. However, the price of import will definitely increase, and thus the revenue of export and import will be like this. So since net export equals export minus import, the net export will actually decrease in the short run. Then let's have a look at the long run. In the long run, the price of export and import will be same as the short run, constant and increase. However, in the long run, the PED is relatively more elastic now. As a result, the export is now relatively cheaper and the import is relatively more expensive. As a result, their quantity demanded will increase and this will decrease. So we can see that the revenue of export will definitely increase. However, we cannot just decide the revenue change in the import because these two are conflict each other. So this is why the economics are creating the inequality of Marshall-lerner condition. It help us to decide whether the depreciation and appreciation in currency will lead to worsening or improved current account. So now let's try to prove this Marshall-lerner condition in a mathematical way. These are the abbreviations: export, import, net export, and E is the exchange rate. I will have to stress that the exchange rate here means the price of one currency in terms of domestic currency. Yeah. Firstly, we all know that net export equals export minus import, and then we use a derivative. And as for the part here, we change it. We all know that import equals the exchange rate times the quantity of import. And then use a product rule. And then we insert the result here into the previous equation. And we divide this equation by export. we all know that when in equilibrium, the net export equals 0 and export equals import. Also equals exchange rate times the quantity of import. And thus the equation here is changed to can you see the logic here? Because E over export equals 1 over quantity of import, and this also equals 1 over exchange rate. This can be derived from this equation. Yeah. And we times AE on the both sides of this equation. Okay, now let's leave this equation for a while. Let's see what is really the PED. It equals the change in percentage of price divided by change in percentage of the quantity. Equals this, right? Then we further simplify this. And we notice that the P here equals exchange rate. So the PED of export equals times, to simplify this equation, in the same way we can get that the PED of import equals to because they're exactly the same. Yeah. And we can see that magically the PED of export equals this part, and this part is the PED of the import. So let's insert this 2 PED into the previous equation, then we can get that. Now, back to our Marshall-lerner condition. We know that if the currency depreciates, then what will happen? When the currency depreciates, the domestic currency is losing its purchasing power. As a result, let's back to our abbreviations here. E equals exchange rate. It is the price of one currency in terms of domestic currency. As a result, when the domestic currency depreciates, the E will increase. Okay, depreciation, E increase. And according to the Marshall-lerner condition, then export will increase. So we can see that. And we know that the exchange rate is bigger than 1, so is the export. As a result, on the left side of this equation, this part is bigger than 0, so is this part. As a result, PED export minus PED import minus 1 is bigger than 0. Thus, okay, we are approaching the end. We all know that the PED is the negative number. So this equation generally means the distance between PED export and PED import is bigger than 1. Let's draw a number axis 0. Even if, let's imagine, one of them equals 0. Equals 0. Because the distance between them is larger than 1, so another number must be on the left side of negative 1. Then we can see that the sum of distance from these two numbers to 0 must be bigger than 1. So distance is bigger than 1. Yeah, then you see we have successfully proved the Marshall-lerner condition. If you like this video, I would really appreciate it if you smash up the like button below, and if you're really enjoying this video, consider subscribing with notification turned on. I'll see you next time.